Welcome back. Let's discuss a couple of theorems related to isosceles triangles. Before we do that, we need to understand the names of the parts of an isosceles triangle. So if I have a triangle and I mark these two sides the same, these are congruent to one another, which is what makes it an isosceles triangle. We have at least two sides that are congruent. These two sides are called the legs of the triangle. Well, I guess it's leg, not legs. And then the third side would be the base. Where the two legs meet, this is called the vertex angle. And these other two are called base angles. So we've got a base angle there and a base angle here as well. So those are the parts of an isosceles triangle. Now we have two theorems related to this. We have the Isosceles Triangle Theorem, which says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. In this triangle, I've got these two sides congruent. So across from that is this angle, and across from that is this angle. These two angles must be congruent. Now, where that's useful is if I have a triangle and these two sides are given to me, and maybe I know this is a 70-degree angle, then I would immediately know that this is also a 70-degree angle. But it can also be used to do more than that. Let's say that this was described as an expression. I would know that those two have to be equal to each other, and I can use algebra then to find an x value or something like that. Well, there's a theorem related to that. It's called the converse to the isosceles triangle theorem. And of course, converse means you switch the parts of your statement. So what we do here is instead of starting with the sides and concluding something about the angles, we're going to start with the angles and conclude something about the sides. It says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So I see here that these two angles are congruent. So across from that is this side, and across from that one is this side. Those are congruent. So when I see these angles congruent, and let's say I was told this is 10, then I would immediately know that this one is also 10. Or, just like before, if I had a statement like this, describing the length of it in an expression, I would know these two must equal each other, and I can solve for a missing value like x equal 12. See you next time.